Now we're ready to get instances that have already been created in our object pool and are deactivated and reactivate them. To do this, let's open back up our object pool class. Now we're going to modify the next object pool method in order to go through the list of instances we've created and see which ones have already been deactivated and then return those instead of creating new ones. To get started, let's add some space right below where we create our instance reference. We're going to use a for each loop to iterate through our pool of instances. We're going to create a variable called Go, representing a game object, inside of our pool of instances. As we loop through this, we're going to test each game object to see if it's set to false. Now, since this is actually typed to a recycled game object, we're going to need to get a reference of its own game object. Then we can call ActiveSelf. Here we'll see if it's not set to true. Now we can set the instance to the game object, and we'll change the instance's transform position. Now, in the event that we've not found an instance that's ActiveSelf is set to false, what we're going to do is create a new instance. So in this case, we're going to write if instance equals null. Here we'll just indent this line. So if this condition is null, we'll create a new instance, add a line break, and either way, we should now get an instance, either from the pool of objects that have already been created, but one that is set to false, or if we can't find one there, we'll simply create a new instance. And we're always going to make sure that instance gets restarted. Let's save this, go back into our game, and take a look at how this works. As the game's running, we'll see our object pool gets created. Let's open this up, and we should now see that when an object gets grayed out and a new one is requested, it'll now become active again. If you remember back, we had this huge list of game objects that kept getting created. But now we can run this game, and our object pool has scaled up to the maximum amount of objects it needs to create. And now, at this point, we'll not incur any more overhead for creating new instances or requesting them because they'll be scaled up. Here you'll see a new instance was created before we had one ready, so it's scaled up to 4 from 3. This is important also because our spawner doesn't always spawn the instances at the same time. Now we have this range between the delay. So there may be cases where this might actually jump up to 5. But either way, we're still saving a huge amount of memory and resources by recycling what we've already created. Next, we want to make sure that not only can we call the reset method on anything that has a recycled game object script, but we want to be able to add that functionality to other scripts so we don't have to force ourselves to always be extending the recycled game object script for each of our recycled objects.